Okay, here we have a question about a sphere which is falling through a fluid and is traveling at terminal velocity. Let's have a look at the question, and then when we're ready to see the answer, hit play. So terminal velocity, we should be aware we're in a state of equilibrium, dynamic equilibrium, whereby we're moving, however the forces are balanced. Okay, so what we're looking here is the fact that force of gravity is equal to the drag force acting on the fluid. Okay, now what we want to do is try and relate those two. Well, we know that gravity is mass, the gravitational force, I should say, is mass times the gravity. And then we've got our drag force here, which includes our viscosity. Now, obviously, we don't have a relationship here between radius. That's what we're really interested in here. We've got the two radius, so we're going to try and get that in here. We know that our mass goes with density times volume. We've got a sphere, so a very common trick is to look at the fact that we've got 4 over 3 pi r cubed, that's the volume of a sphere, times its density, times g, that's the g from the previous equation, and that's still equal to 6 pi times our viscosity times the radius times the speed. Now at this point, what we're going to do is we're going to cancel one of those r's, so that we've got 4 over 3 pi r squared is equal to 6 pi viscosity times v. So hopefully now you can see that what I could do is divide both sides, for example, by this constant here. I would be able to see that the speed goes with r squared. Why is that important? Well, what we're doing here is we are doubling some quantities. In this case, we're specifically doubling the radius. So we're going from r to 2r. That means r squared goes to 4r squared. If r squared goes to 4r squared, v is going to go to 4v, which is why the answer here is D. Now again, I've said this many times in these kind of questions. This is a sort of numerical manipulation question, which you just need to be aware of what variable is changing and how might that possibly affect the other variables in the question. So take some time to have a little look at that question, make sure you're comfortable with the forces analysis, and if you're ready to watch the next video, please move on.